Hi everyone, today we're going to talk about log functions, something that you should be familiar with. You went through it in Algebra 2. You learned a little bit about them. We're going to talk about them today. We're going to sort of go through the basics of log functions. Tomorrow's class will be about the properties of log functions, and we'll start talking about solving log equations and things like that. So let's get through the basics today. So what is a log function? A log function is simply the inverse of an exponential function. So in the graph on the screen, you'll see in red I've got the exponential function y equals 2 to the x. You'll see, and we talked about this when we talked about exponential functions, the graph goes through the points 0, 1. And if you think about the domain and the range, right, the domain is all real numbers. The range is greater than 0. Okay, so you'll see that there. You also see the line y equals x. The definition of an inverse of a function is when you reflect it over the line y equals x. So if I literally just take each point that's on my exponential graph here and I reflect it over that line y equals x, I end up with this blue curve, and that is the log function. So you'll see here, I take the point 0, 1 and reflect it, I end up at 1, 0. I take the point 1, 2 right here and reflect it, I end up at the point 2, 1. And you do that to all of the points and you end up with your log function. So in general, this would be the general form of that. Okay, so this was a very specific example with y equals 2 to the x. Here is the general form. So if I have an exponential function, when I take the inverse of it, I end up with the log function. So that's what it looks like graphically. Before we get into the whole idea of log functions and how we find them and how we manipulate them, let's just look at this graph a little bit more. We just said, and we talked about this when we were talking about exponential functions, we said for an exponential function, the domain is all real numbers. So the domain is from negative infinity to positive infinity, and the range has to be positive. But now let's look at the log function. This was for the exponential function. But let's look at the log function. Our domain for our log function has to be everything greater than 0. You can see that from the graph. All of our x values are greater than 0. But our range values, we go forever in the negative y and in the positive y direction. So our range goes from negative infinity to positive infinity. And so you can see that not only do all of the all your x and y's flip, right? You just changed your x and y's to get the log function. You also just flipped your domain and range to get the domain and range of the log function. Okay, so the inverse of an exponential function is a log function. How does that work, or how do we do stuff with that? Well, if I have an exponential function, so I have the exponential function y equals b to the x, and we just said to find the log, you just take the inverse of that. The inverse of that is just switching x and y. So if I go ahead and switch x and y, I end up with x is equal to b to the y. Okay? The problem is I don't know how to solve for y when y is my exponent. And so that's where the whole idea of logs come in. I can rewrite this. And in words, if I look at this, I'm saying, well, y is the exponent, right, of base b that gives me x. So y is the exponent, but I'm not going to write the word exponent. I'm going to use the word log. It's just another way, it's another word for exponent. Okay, so y is the exponent of base b that gives you x. These two equations are equivalent to each other, and that's what a log function is. Okay, so this is exponential form, this is log form. Let me give you an example. If I have 2 to the third is equal to 8, if I wanted to write that as a log function, 2 is my base, 3 is my exponent, and 8 is what I end up with. So if I write that out, I say log base 2 of 8 is 3. Okay, that number that's all by itself over here, that is your exponent. Your base is whatever your base is here. That's a subscript 2. And we say this log base 2 of 8 is 3. And that's how we would explain that out. That's how you would write it. So you can easily switch from log form to exponential form and vice versa. So if I gave you the equation log base 5 of 25 is 2, and I said, well, write that in exponential form. Here's my base, here's my exponent. So I would have 5 squared is equal to 25. So that's just a quick review of log and exponential functions. Let's talk a little bit more, and that's how you would change back and forth between them. But let's just talk about how you can evaluate logs depending on how they're written. For example, if I gave you log base 5 of 125, and I just gave you that and I asked you to evaluate it, all I'm saying is 5 to what power gives me 125? Well, you would say, well, 5 to the third gives me 125. So the answer to that is 3. Okay? You could say, we could do something like this. Log, let's go with log base 2. Log base 2 of 1/8. Okay, so I'm saying 2 to what power gives me 1/8? Well, this requires a little bit more thought. Okay, so I'm saying 2, that's what I'm saying, 2 to what power gives me 1/8? Well, I can rewrite 1/8 in base 2, or I can rewrite 1/8 as 1 over 2 to the third, which is the same as saying 2 to the negative third, right? A negative exponent, so here's a quick review. A negative exponent takes something from the numerator and puts it into the denominator, or vice versa. So the negative exponent just changes the position of where that number is in the fraction. Okay, that's all it does. So if I have 2 to the y is equal to 2 to the negative third, it's pretty easy to see that y has to be equal to negative 3. Okay, so these are just some examples of how you would go about solving a problem like this. Okay, here's one that's a little bit harder. If I have log base 2 of the 5th root of 2, and I asked you to solve that, I'm saying, well, 2 to what power gives me the 5th root of 2? Okay, what I'm saying is, how do I figure this out? So 2 to what power, that's a y there, 2 to what power gives me the 5th root of 2? We'll go back to what you learned about exponents. All right, if I'm taking a root, I can write that as a fractional exponent. So the 5th root is 2 to the 1/5 power. The square root would be 2 to the 1/2. Third root would be 2 to the 1/3. Fourth root would be 2 to the 1/4. Okay, so same idea as over here. I now know that y has to equal 1/5. So don't let when you see different problems like this, don't let that get you all flustered. It's just a matter of take it out of log form and write it in exponential form, and then get those bases to be the same. And when you do, the exponents have to equal each other. Okay. Let's talk briefly about switch screens here. There we go. Let's talk briefly about a couple of things having to do with logs. So, for example, can I take the log of 0? So if I gave you this problem, log base 3 of 0, and I said, well, evaluate that for me. And you might say, okay, well, if I put that in exponential form, that's the same as saying 3 to some power equals 0. And then you're trying to figure out what the power is. Well, is there any number or any number of times I can multiply 3 together by itself and get 0? Because that's what this exponent means, right? It means I'm multiplying 3 by itself a certain number of times. There's no number that I can plug in for y that's going to give me 0. So I cannot take the log of 0. Similarly, I also cannot take the log of a negative number. So let's say we have log base 5 of negative 25. Well, if I were to write that in exponential form, I would have 5 to the y is equal to negative 25. Well, there's no way to take a positive number and multiply it by itself any number of times and get a negative number. It's impossible to do that. Okay, so the idea here is this: you cannot take the log of 0 and you cannot take the log of a negative number. Go back to the graph and you'll see that here, right? When we said the domain has to be greater than or equal to 0. The domain is never going to be 0, it's never going to be negative. Okay, same idea. I cannot take the log of a negative number, I cannot take the log of 0, because it simply doesn't exist. Okay, so that is a quick overview. A couple other quick rules for you, basic properties involving logs. If I have log base b of b, that is going to equal 1. It has to. Think about it. If I did a numerical example, if I had, well, log base 4 of 4, I'm saying 4 to what power gives me 4? Well, 4 to the first power gives me 4. Okay, that's what that means. Also, if I have log base b of 1, what is that equal to if I gave you this? Well, let's do a numerical example. If I had log base 7 of 1, I'm saying 7 to what power? 7 to what power gives me 1? Well, to get 1, I would always be raising to the 0 power. Anything to the 0 power is going to be 1. So log base b of b is 1. And log base b of 1 is 0. Those are two properties that you want to make sure you're familiar with and that you know. And one other quick thing just to be aware of, and this should again is all review for you. When you are talking about base 10, right, our number system is base 10. When you're talking about base 10, so if you see log of 100 or log of 1,000 or anything like that, and there's no base written, that means it's base 10. You can assume it to be base 10. It's the same idea where if you're writing an equation and you have x squared and there's nothing written in front of it, it's just 1. Same thing here. If there's nothing written there, it's base 10. Okay, so this would actually be equal to 2 because 10 squared is 100. Okay, so there's basically saying 10 to what power gives me 100? Well, 10 to the second power gives me 100. So that is a quick review of logs. We're going to talk about them in more detail tomorrow. This will help you get through your assignment for tonight, and I'll see you all tomorrow. Have a great day, everybody.